preparing. All right, recording. All right, last lesson of Unit 4B. We have a little review coming, but this is the last new thing we have to learn for months. All right, so think about that. It's great. All right, we're talking about density. Density. Okay, so if I have two objects, I have this beanbag kind of thing, and let's see, something like an apple. So I got apple and I got the beanbag thing. Which one has more density? What would you say? Tell your neighbor which one is more dense. What does it mean for it to be dense? In fact, I'm gonna switch it up. I'm gonna go with foam block, and apple. Which one is more dense? Tell your neighbor what you think. It makes you think about what density is. What do you think? All right. Which is more dense? Foam block or apple? That's the question. All right, let's see. Ooh, I don't like that. All right, let's see. Estrella, what do you think? Which one's more dense? The apple. Everybody agree with that? Was that like an easy question? Right? Density, how would you describe density? It's what? Not sure? You guys know what you don't know, right? It's almost like there's more stuff. There's more matter. It's more densely packed. When something's really densely packed, right? If this thing right here was like lead or gold, it'd be super heavy, right? This thing, if it was gold, would weigh a lot. Okay? Just like if it was a rock, it would weigh more than the apple because a rock's more dense. This one's really spongy. It has a lot of air in it. It's a foam. So we're talking about that. That's what we're talking about in particular. The only thing we need in order to figure out how dense it is we have to know the mass. Okay? So that's like a quantity. It's not necessarily just like thinking of it as weight, but it is a mass, a quantity, over the number of square units. So if this was like a giant apple, right? Then I would have a huge volume, and it would affect the density. The mass would also go up as well, I guess. So it would balance it out. But we're dividing by the square units or the volume. Okay. So this is pretty much. You might write this in here. This is related to weight. Might draw a little scale, right? It's to weight, and this is how big it is. Okay. So you have the weight on top, you have how big it is on the bottom. You can have two different kinds of density. It's area or volume. And then who saw this and is kind of confused what this symbol is? Everybody? You don't know it? The symbol is rho. Okay. It looks like kind of a cursive P, but it's not very neat. Actually, it kind of looks like a leaf. It's a leaf of a flower. How about that? We'll call it that. All right. That work? All right. So if I'm looking for the density of it, I'm an artist. Huh? Flower. All right, now I'm officially an artist. Cool. Flower pot. Flowers can just grow in space. Okay, they can't find it. Someday. No, it's already happening. I'm just behind. All right, so the density of the area would just be the mass or the amount you have divided by the square units. The main thing, the hardest part, is going to be figuring out when they give you information, is it talking about this or is it talking about this? Okay, so put these in here. Put these in here. Examples of mass might be grams, right? Might be grams, kilograms, pounds, right? You might also have a quantity, like you might have, 1,000 people, right? So those are all examples. Whenever you see in the word problems we're going to do, when you see these kind of parts, you know that's where it goes in the formula. Down here, number of square units, you could say, we're talking about, what could be square units or it could be cubic units. So this could be giving you an area, giving you dimensions. Dimensions, okay. Let's see. You'll see either like meters squared or meters to the third if there were meters, okay, because those are area and volumes. Right. So you got an idea of what goes where. I hope that's the hardest part. Once you know that, the problems aren't that hard. So let's see. Let's take a look at this. So example 1. a 10 centimeter cube sample of copper has a mass of 89.6. What is the density of the copper? So let's put in our density formula. It looks like right here. This is a third exponent. What does that imply? Are we talking about area, volume, distance? What's the third exponent? Cubed, right? Cube. So if you have a cube, right, centimeters cubed, you're talking about dimensions that are length, width, and height. So in this case, I know that we're talking about the density of the volume density here. So I'm going to put volume density. That's what we're trying to find out. What value goes on the top? Go ahead and put it on the top. We're going to put something here and put something here. Go ahead and figure out, based on the info, you have to just pretty much figure out, is it talking about mass quantity or square units, cubic units? Right. Victoria, what goes on the top? What do you think?
Oh, wait. No, sorry. My bad. 89.6.
And why did you change that? You're right.
Yeah, because I saw mass of the copper.
Good. Mass of, and we have grams. Wow. We know that grams, it's a mass, okay? So I put 89.6 grams. All right. Let's see. The other one we know, right? They give you a question, what's the density? So I know that's going to be not given to me. I'm going to find that. So what has to go down here? 10 centimeters cubed. All right, go ahead and divide 89.6 by 10. We're going to find our density, volume density here. When you divide by 10, you should move the decimal. So it might be pretty easy to find.
Oh.
Right? You have 89, you divide by 10. Think about it that way. And we're talking grams per centimeter cubed. Go and leave it in the units that they're given. We're not dealing with, like, getting it always in milliliters or kilograms. That's not this class. So we're going to leave it in the units that they give us. Don't worry about the unit conversion. But here we go. The density of volume is just this. Okay. And this is the density, if these are correct figures, that's the density for copper for any amount. If I filled this room with all the copper in the world into one big block, right, it would still have this density. We would just have a way larger mass and a way larger volume that fit in. So far, so good? Nice last lesson. All right, we got one more part. This is the only other thing you'll see. Only other part that you'll be facing today. And let's look at it. A substance from Neptune has a density of 10 grams per milliliter. That's fine. It occupies a volume of 80 milliliters. What is its mass? Okay, so let's see. We have a density. It's talking about volume, so I know it's another density volume problem. And I'm just going to write here, we have a mass, and we're going to have a volume. Okay, so I want you to rewrite this. What goes in each of these boxes? What's going to go in each of those boxes?
So, for the first box, on
Yeah.
the black one, D10 G over milliliter.
Perfect. Neptune has a density of 10 grams per milliliter. Okay.
And then,
Yeah, keep going now.
the 80 would go on the bottom.
80 because it's the volume.
Yeah.
You know that's cubic units, so that's cubic, that's volume.
Yeah.
I like it.
When just like a X roll.
I like it. When you don't know what a value is, that's going to be our unknown. That's our x. All right, so double check that you have it set up this way. It's one step solve. I'm going to rewrite this a little more concise. How do I isolate x? Tell your neighbor what's going on between 80 and x. Do the opposite operation. What's going on? All right, bringing it back. Let's go with Adriana. Help me out. What should I do to solve for x?
Would you multiply each side by?
Yeah, watch what happens. 80, 80, gone. So X, the mass of this is 800 grams. And I look at the units, right? They said the density was actually grams over milliliters, so I know that this is going to be grams over milliliters. If they give you the density, it tells you, right? They could have said the density was 10 kilograms per milliliter, right? If they had strange units, then I would know that the mass had to be in kilograms. Stay with whatever units they give you. How's that? How's that? Thumbs up, sideways down. That one felt pretty smooth. We're good, right? Yeah, we're all good. All right. You guys have 10 problems. It's on Edmodo. I'll put it up. But there are problems like this. Work with a partner. Headphones are fine. It's just kind of like a, yeah, it's a work day. We got it. Yeah.